Before we begin the tutorial, if you're interested in engineering simulations, coding tutorials, and more, be sure to hit the subscribe button and turn on notifications. Also, feel free to drop any questions or thoughts in the comments below. I'm always excited to hear from you. Now let's begin. With the blank model page open, click on the library icon. Scroll down, click on Simscape. Click on Specialized Technology, open the Fundamental Block menu, and add PowerGui to the blank model as shown on the screen. Open Electrical Sources and add DC Voltage Sources component to the model. Open Elements, add Series RLC branch to the model. Open Power Electronics, add diode to model and MOSFET to the model. Open Measurement, add current measurement and voltage measurement components to the model. Scroll up to the Simulink menu and open Sources. Add Pulse Generator to the model. Open Commonly Used Blocks, add Scope to the model and close the library. Let's separate the components on the model to start building the circuit. Open the Model Configuration Parameters icon. Under Solver, click on the dialog box and select ODE 45, Dormant Prints. Click Apply and OK. Open the properties of the DC voltage source component and change the amplitude to 200. Apply the changes and close properties. Open the properties of Series RLC branch. Change the branch type to L, and the inductance value to 500E6. Apply the changes and close properties. Connect one port of the inductor to the positive of the DC voltage source. Rotate the MOSFET such that the drain and gate face upwards. Open the properties of the MOSFET and unclick Show Measurement Port. Apply changes and close. Connect the drain of the MOSFET to the inductor, and the source of the MOSFET to the negative of the DC voltage source. Connect the pulse generator to the gate of the MOSFET. Open the properties of the pulse generator. Change the period to 1/20,000th, and the pulse width to 70. Apply changes and close properties. Connect the anode of the diode to the drain of the MOSFET. Duplicate the inductor. Open the properties of the duplicated, change branch type to C, and the capacitance value to 100E6. Apply the changes and close properties. Connect the positive port of the capacitor to the cathode of the diode, and the negative port to the MOSFET source. Open the properties of the diode, and unclick Show Measurement Port. Apply changes and close. Duplicate the capacitor. Open the properties of the duplicated capacitor and change the branch type to R. Change the resistance value to 50. Apply changes and close properties. Connect the positive port of the current measurement to the capacitor and the negative port to the resistor. Connect the other port of the resistor directly to the capacitor. Connect the voltage measurement to the resistor, and to the DC voltage source. Right-click on the scope, under Signal and Ports, select 3 for number of input ports. Connect the voltage measurement at voltage source to the first port of the scope. Connect the voltage measurement at the resistor to the second port of the scope, and connect the current measurement to the third port of the scope. Open the scope, click on View, and under Layout select 3-block layout. Select Style under the View menu and make any changes that you would like the signal display to be. If you don't want to make any changes, close the Style box. Note that you must apply any changes you make to any active display before moving to the next. After making all the changes you want, close the scope. Change the time to 2 seconds. Open the scope and click on the Run button to simulate. From the result shown by the scope, The voltage measured at the input from the DC voltage source is 200 volts and the voltage at the output measured at the load resistor output is above 600 volts, indicating a voltage increase. Although the current at the output is low, less than 15 amps. Thanks for watching. If you found this tutorial helpful, don't forget to like this video, share it with others who might benefit, and subscribe to the channel for more content like this. I'd love your feedback or any questions you have in the comments. Let's keep the conversation going. See you in the next video.